Today we're going to work with standard form again. That's what we did yesterday. But we are going to do it by, instead of doing the x and y intercepts, we're going to take standard form and move it into slope-intercept form, which is what you see here. So we actually did this in our first unit when we solved equations. You guys had something in standard form and you actually solved it for y, so we have done this before. The only difference about today is that you're going to go ahead and solve it, and then I'm going to ask you to start graphing it. So our steps here, and you've seen these before. The first thing that you'll do is move the x term to the other side. You'll do that by either adding or subtracting, so that's what you see happening right here. Once you do that, you are going to divide by the number that's in front of y. So that's what you see happening here. We're dividing by that b in front of y. And then you write it in slope-intercept form and simplify both fractions. So we have done this before. If you feel like, this is familiar, that's a good thing because we actually did this when we solved equations. Okay, our first example, we're going to write the steps as we go. The first thing that you're going to do to find the slope and the y-intercept, we're just getting this solved for y, so it's y equals mx plus b. So step one, move the x term to the other side. So in our case, we have negative 5x minus y equals negative 2. So to move the negative 5x, I'm going to add 5x, and I'm going to draw this little bouncing line here. Okay, I'm going to add 5x. To move it to the other side, since it's negative, I do have to add it. Okay? I gave you a lot of space here. Oops. Okay, I'm going to write it way down here. Negative y equals negative 2 plus 5x. Then step 2 is to divide by the number in front of y. Okay, so in front of y you have a negative 1, so you need to divide by negative 1 on both sides, so that your next equation, we're going to make sure we simplify our fractions. And then write it in y equals mx plus b. Okay, negative 1 divided by negative 1, now I have y by itself. And I have to simplify both of these fractions. We'll do this one. Negative 2 divided by negative 1 is positive 2. And we're also going to do 5 divided by negative 1, which is negative 5. So negative 5x. If this freaks you out, then you can rewrite it as negative 5x plus 2, so it's exactly y equals mx plus b, but it doesn't really matter as long as you pay attention to what number's in front of x, because that's your slope. So my slope is negative 5, and my y-intercept is positive 2, which you can write as a point if you went like this, 0, 2. So when you have the slope and you have the y-intercept, you can go ahead and graph this on a grid, which will be part of your homework today. Okay, this one doesn't have steps, so we're going to put it into slope-intercept form by solving for y. So move that x term, you can draw a bar if you want. Move the x term to the other side. It's positive, so I will subtract it. And get negative 4y equals 24 minus 3x. And then I divide by the number in front of y. And I get y equals 6 minus 3/4 x, because 24 divided by 4 is 6, and negative 3 over 4 can't be simplified any further. Okay. If this freaks you out, you can rewrite it, remember, as y equals negative 3/4 x plus 6. That means my slope is negative 3/4 because it's the fraction in front of x. And my y-intercept is 6, and that's a point. Now, I should have included a graph on this one, but I didn't. So I'm just going to go ahead and make sure I cover that with you. I now know my slope is negative 3/4 and my y-intercept is 6. So that means my y-intercept starts at the point 0, 6, and my slope goes down 3, right 4. So it's a nice negative slope. So when you have something in standard form and you move it into slope-intercept form, once you do this, you can actually graph it in y equals mx plus b. So I'm going to do that on this little grid over here. I'm going to start at 6, and then I'm going to go down 3, or right 4. Whoop, down 3, right 4, and then reverse the other way. Up 3, left 4, and that should be good enough. Okay, and then you connect those points with the line just like you did in 3.3. You graph the same way. Once you have it in slope-intercept form, you can graph that. Okay. Last one. You are buying hamburger and chicken for a party. You have $60 to spend. The hamburger costs $2 per pound and the chicken is $3 per pound. Write and graph a standard form equation that represents the different amounts of hamburger X and chicken Y that you can buy. All right, this is an equation that you can write in standard form. So you have $2 per pound of hamburger. So let X equal the pounds of hamburger, and I'm going to say like this, pounds of hamburger. And then Y is the pounds of chicken. All right, $2 per pound. So remember, when you're having a word problem, variables go next to numbers that happen over and over. So $2 per pound of hamburger plus $3 per pound of chicken, so they both get a variable, equals 60, which is my total. So that's an example of an equation written in standard form. It's a word problem. You're going to do this when we have word problems. I feel like usually it's the easiest to go ahead and move it into y equals mx plus b, so you can graph it. So I'm going to go and do that by moving the 2x over. That way I get 3y equals 60 minus 2x, and then divide by 3 on both sides, the number in front of y, and simplify. 60 divided by 3 is 20. And then negative 2/3 can't be simplified anymore. Leave it as a fraction because you're doing slope. Okay, that's my equation in y equals mx plus b. So this is the thing that I'm going to graph. Now, conveniently, on this grid, there is actually 20 squares. If you don't believe me, you can count it yourself. X and y, here's my x and y axis. This is just one corner of the coordinate grid. It's all the positives. So the x is the pounds of hamburger. So on the x-axis, I'm going to label it hamburger, and my unit is pounds. And on the y-axis, I'll put chicken, and my unit is pounds, LBS. And you can zoom in and check if you need to, but each of these squares is going to be worth 1 because I believe there's exactly 20 grids. So 4, 5, 15, 2, 3, 4, 20. Okay, so I'm labeling every 5. You can label every 1 if you want to, but I'm kind of lazy, so I'm not going to do that. All right. And now we just graph it in slope-intercept form. So I know that my y-intercept is going to be 0, 20. And my x-intercept, or sorry, not my x-intercept, my slope is -2/3. So this is b. M is -2/3, which is going to mean that it goes down 2, right 3. So I start at 20, because that's my y-intercept, all the way up here. Whoop. And I go down to right 3, over and over and over. Now here's the problem. I kind of screwed this up because realistically we would like to be able to go all the way to the bottom, but you know, Mrs. Brandt messes up from time to time. So here's what I'm going to do. I'm going to make a line and just keep it going, because it would keep going all the way down to actually 30. So it would keep going, and then it would hit the grid at 30. And that's my mistake for not making a bigger grid, but oh well. So that means that my domain from left to right, it does start and stop. So the farthest it goes to the left on the x-axis is 0, and then it goes over and stops at 30. And the range, lowest to highest, range starts at 0, and then it goes up, stops at 20. So my range is from 0 to 20, and I used y. And the reason I knew the x-axis was going to stop at 30, by the way, is because I can take my equation 2x plus 3y = 60 and solve for the x-intercept. If I do that and plug in 0 here, and this basically cancels out, I get 2x = 60, and then I divide by 2, and x is 30. So that's how I knew it was going to hit at 30, 0, even though I kind of messed this one up and should have kept it going. So that's how I know the domain is going to stop at 30. So what these points mean is that in all these points where it hits, like right here, it represents a combination that you can have. So like this is the point 9, 14. What that means is one of the combinations that you could buy is 9 pounds of chicken, no, not chicken, burger, and 14 pounds of chicken. That's just one combination. There's lots of combinations you could have, right? Because here's another one, 3 and 18, etc., etc. So all of those points work in the domain and range.